We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
What role can artificial intelligence play in shaping the future of energy systems? Hosted by Dr. Aidan Rhodes, a research fellow at Imperial College London and Energy Policy Briefing Papers fellow at Energy Futures Lab, this conversation brings together expert insights into the intersection of AI and energy. Our guests include Francesco Leofante, an Imperial College Research Fellow affiliated with the Center for Explainable Artificial Intelligence. Francesco's work focuses on safe and explainable AI, with a special emphasis on counterfactual explanations and their robustness. We're also joined by Daniel Lewis, a Parliamentary Office of Science and Technology Fellow and author of the recent Energy Security and AI Policy Briefing Paper. Daniel's work explores AI applications in energy systems, the challenges likely to emerge, and key policy considerations proposed by stakeholders. In this episode, they discuss the potential solutions and opportunities for AI within energy systems, the challenges and risks of integrating AI into the energy sector, and how AI could help accelerate the transformation of energy systems for net zero.
Okay, so welcome to another episode of our Energy Futures podcast. I'm Aidan Rhodes. I'll be hosting today's session, and today we're going to talk about AI in energy. So its opportunities in the energy transition, its risks, its challenges, and basically the technology itself. So I'm joined by two excellent guests, Francesco here and Dan. So I'll let them introduce themselves to you. We'll start with Francesco.
So hi, my name is Francesco Leofante. I'm an Imperial College Research Fellow. I'm based here in the Department of Computing. And I'm an AI person. So I've worked over the last about 10 years, I would say. I've worked on many subfields within AI,
Great. And Dan?
I'm Dan Lewis. I'm a fellow at POST, which is the Parliamentary Office of Science and Technology, and I'm currently writing a briefing on this very topic, so it's quite topical.
Excellent. So two excellent guests. And I guess we'll start off by just looking at the energy transition. Like, we got a long way to go. We've got a big transition to do. How can these AI technologies, these machine learning technologies, which obviously are rapidly evolving, actually help? So I'll start with you, Francesco. What do you think is the major area that you think artificial intelligence can help in the energy transition?
Well, I think it's as you said, it's a broad topic, right? So I think anywhere where we need to think about planning operations, optimizing the infrastructure, even all these areas are potential areas where AI solutions. Now, AI is a broad topic, right? So I guess ML and other AI techniques could help. So that's really just one example, but there are so many. Also in your document, I saw so many interesting applications that I was very excited to see many of them.
All right, so Dan, what are some of these interesting applications?
Well, the main ones are to do with actually optimizing and planning optimizing the planning, generation and use of energy. So that's where stakeholders that we've spoken to see as being the real value in. And the government has its targets to decarbonise the grid by 2030, which brings forward the previous deadline 5 years, and a lot of that is going to depend on connecting renewable generation.
Yep.
But what we see with the grid is currently connection delays for renewable energy, and we see bottlenecks with the infrastructure. So actually getting that renewable energy connected is a challenge. So there's potential for AI with its optimizations to help expedite those connections, which should then help with the transition towards decarbonisation and net zero.
So this AI use, what sort of AI would be using here? Presumably not something like ChatGPT, is it?
Yeah, that's exactly.
This is where I think we should maybe talk about some of the different types of artificial intelligence and how they can help here.
Yeah.
So what are we looking at here?
When people hear AI, they maybe jump straight to generative AI like ChatGPT, from the people that we've spoken with, the stakeholders from industry, academia, and NGOs, that's not where the main benefits are going to come from. It's in the predictive AI or the predictive machine learning where the benefits are going to be. We're forecasting and learning from historical patterns to then try and kind of project the future.
So this is basically where you take a large amount of data from, as you say, historical usage patterns, historical generation and demand, feed them into an AI, and it can basically predict the future with better accuracy, maybe?
Yeah, better accuracy and also updated continuously, potentially in real time eventually.
Yeah. Okay, interesting. Well, Francesco, is that something that you've been working on?
Yeah. Actually, in fact, I've worked a lot on planning as in historically understood, I suppose, good old-fashioned AI, symbolic planning. But I've also worked on AI models that are used to predict, mostly in control tasks, I must say, but also more recently, AI models, deep learning models for time series analysis. So these are all domains, they are very relevant, all applications. I think what makes applications in energy particularly interesting is that I don't think you can ignore the physical processes that you're trying to model with AI, right? So I think I see that as a very interesting challenge from, for a computer scientist at least, I see it as a very interesting.
So the physical processes, you mean the minute-to-minute operation of the grid?
For instance, it really depends on what you're trying to where you're trying to apply AI, right? And what you're trying to use it for. But yes, if it is for forecasting, that's one possibility. If it is batteries, charging batteries, optimal charging, you will have different constraints, right, coming from the application. But I think it's very exciting for me to see how and to think about how all these constraints can be incorporated into the AI models, right?
Yeah, so we're not just weather forecasting here. We're attempting to forecast basically a constrained system, like a system which is basically it has to have a certain amount of energy in order to supply demand minute by minute, second by second, and how best to optimize that. So let's just take a step back from that then. So before we had new AI models, how did this work? I might ask Dan here. Do we know?
Well, I think on a general level, the way the system operated is that at times of peak load, it would be the renewable generators that were asked for constraint, to basically payment to lower production to maintain the stability of the grid.
Yeah.
And those costs are ultimately passed on to the consumer.
Yes, because we still need to pay these generators. If it's too windy and we've got too much electricity, we can't just say, sorry, you're not getting paid today, someone else is. So that is the problem with the market, I guess. How can AI help then?
The idea is that if through these optimizations, AI is able to help lessen those constraints, you're able to see increased penetration of those renewable generators, and perhaps a shift from that main backup load being from fossil fuels. Potentially if you're better able to predict more accurately the amount of demand you're going to need to supply, and then the actual amount of generation that's going to be available from those renewable sources, that you can be less reliant on those fossil fuels and move towards decarbonisation.
So just to move back to you, Francesco, so these sort of predictive models, so what sort of data is being fed into them?
Well, all sorts, right? So it really depends. It could be time series data, right? So I'm thinking about smart meters, for instance. If you want to monitor energy consumption, for instance, right, then you'll have a lot of time series involved, and then it's all about trying to identify patterns within this temporal data. But it could also be other things, right? Depending on, I was reading a paper on using images to identify, in fact, to locate solar panels, because they're not necessarily, their locations, especially, those that are sort of private, privately run and used, their locations may not be known, right? So there's, I've seen work done being used to identify
satellite images.
Mm-hmm. Yeah,
we're just looking, say, the solar panel on that roof, and we can see that via a machine learning model.
Yeah. So, and these are just some examples. There are many. I mean, there are many applications, right?
And I guess, would you say the more data, the better always, or?
That's that's a controversial statement, I suppose, because of course, not having data for many, especially when it comes to learning-based AI, right? Machine learning, generative AI, you name it. But when it comes to this data-hungry types of AI, then of course not having data is a problem. However, I am not entirely sure that having more data is the solution to solve all the problems that AI is currently facing, right? And that is also very true in the energy domain, right? So there are some, I guess there are some problems for which you don't have enough data. And then the question there becomes, how can we train AI, meaningful, useful AI models, right, for those domains, for those applications where we don't have enough data. And even when we have enough data, how can we make sense of it, and is it true that having a lot of data will directly sort of result in very good and useful AI models for energy?
Yeah. So would you say it's maybe more about the quality of the data than the...
Oh, that is very important, yeah. It is very important for so many reasons, in fact, because you want to make sure that you have good data to train good models, but you also want to make sure that you have, balanced data sets. You don't want your model to be unfair and biased, right, because you don't have good data, right? So this is a very important problem that of course will also play a role in the energy domain. If you think about the applications of AI here, energy is a very consequential sector and applications, right? So you really want to make sure that when you use AI, you're using it for the right thing,
Yeah, and I think we'll talk about some of that in a bit later on, because absolutely the issue is this energy is a critical sector. It's critical to our economy. It's critical often to keeping people alive, especially with these cold winter months. So yes, we need to make sure we get it right. So let's move back to you, Dan. So you're currently writing a paper for a post note, I believe they're called.
Yeah, that's right.
What are your stakeholders that you talk to most excited about in the field of here in this sort of the near term? Where's the excitement coming from?
I think it largely comes from the capacity for automation.
Yeah.
So not like all these things are done currently by people or with algorithms that are established, but being able to do things faster with more accuracy and therefore improve the efficiency of the whole system is where the real excitement is. And some of the stakeholders see this as almost like a new industrial revolution, whereas others are more reserved and see it more just as a tool and to be cautious with it. And it's only as effective as the regulation, everything that surrounds it.
Well, that's a very good point. And yes, I mean, there is, I think, I've seen this myself, this divide between this is exciting, this is going to actually change the way we do everything, as compared to this is a more sophisticated but still a tool, and we will still carry out business in much the same way, just more effectively, because we have a more effective tool, a bit like a more effective word processor or a more effective spreadsheet. So do you have a view on this at the end, or are you still thinking about the...
Yeah, I mean, I'm slightly limited in my capacity because Post is impartial.
Yeah, of course, yes.
So in that respect, I can't give my personal opinion, but I can reflect the views of the general stakeholders. It is a spectrum. Yep. I'd say the majority more optimistic, but there is a few specifically in industry that are more reserved.
Would you say that the sort of, I guess, the more traditional sort of power engineering people are the more reserved types, and maybe the sort of technological people are the more... No.
And that maybe comes from one of the barriers being the culture in the energy sector, that there's maybe a resistance to rapid change and a more conservative management culture, which, although done for the right reasons, some of the stakeholders think holds back innovation.
Yeah, and of course this is, I mean, obviously energy is inherently a bit conservative because we have one energy system, and if we break it, we don't get the lights on anymore. So there's always this kind of attempting to, design the airplane when you're flying the airplane kind of view of the energy sector, which I think leads itself to these conservatisms. So let's move into a little bit about, because you mentioned regulation before, and obviously regulation is a very interesting and important part of this entire thing. So I would move this back to you, Francesco. What are your views on what Ofgem and other regulators indeed should be thinking about when they're thinking about AI for these more critical sectors?
Yeah, so Let me start by saying that, of course, this is a very tricky topic, right? Because with the technology moving so fast, I guess it's very hard for the policymakers, to just to even keep up, with all the developments. But now, back to your question, I think there is a lot around, as I said, making sure that when we train AI models for applications in energy that involve people and lives, we need to make sure that these models are safe. We need to make sure that they comply with our expectations, right? We need to make sure that they are somewhat aligned with our values. We need to make sure that whenever these models produce decisions, we can understand them, we can explain them, we can logically, explain the rationale behind these decisions. So in my view, these are all important points that need to be crystallized, in law, right? In policy.
Yeah.
There is also a topic that I also mentioned when Dan and I met the first time. And I think there's also a very important aspect of making sure that AI is designed to be contestable, meaning that you want to make sure that there's a possibility for human users to interact with AI and correct it, for instance, or flag decisions that are potentially not good, right? For whatever that means, whatever good means in a specific.
So we should just have a kind of, I guess, black box system where we stick in input to one end and the AI says do this, and we do this without.
I clearly don't think this is possible in the energy domain, right? And it's not just the energy domain. There are also other applications, safety critical applications, where you clearly don't want to have that, right? You want to make sure that if the AI says whatever it says, there is a valid reason for that.
Yeah, I mean, I guess healthcare, transportation, things like these, where there's imminent risk to life.
Exactly.
So I guess, yes, and this is more, I guess, a pressing ethical concern than, say, asking ChatGPT to write your essay for you. No one's necessarily going to die immediately. So yeah, let's talk a little bit about explainable AI then, because I know this is something which you've been working on. So maybe just let our listeners know, I guess, what a non-explainable AI system is, and what an explainable AI system is.
Yeah,
basically.
So I would say that broadly speaking, an explainable AI system is one that whenever it produces a decision, it also explains how that decision was reached, right? Yeah. So it's not just about predicting, I don't know, if we talk about forecasting energy demand, for instance, right? It's not just about saying, oh yeah, in the next few hours we will have this demand, But then it's also an explainable system is one that tells you, oh yeah, and this prediction is based on, for instance, previous observations, right? Other data points that I've used for training, and now I can tell you that I can use as evidence, right? I can use these data points as evidence, or anything that could help users understand how a prediction was produced, right? So a system that doesn't do this is not explainable. Now within computer science and in general when people talk about explainability, there's a lot of there are different names, right? Do you want your system to be explainable? Do you want it to be interpretable? Do you want it to be transparent? And I know that this can be very confusing, but I think the main, the core property that we want to have is, and that we want to ask of an AI system is, as I said, its ability to show why a given prediction was made.
Yes.
Right?
So it's not like, for example, ChatGPT, which just churns out an answer but doesn't explain how it got to that answer.
Yeah. So that is tricky, because when you interact with systems such as ChatGPT and the likes, of course you can ask them to explain how they produced a given piece of text, for instance. But it's even more trickier there, because we know that these kind of generative AI models, they suffer from from hallucinations, right? So they produce, if you ask them, okay, fine, I love the email that you wrote, but now explain why you wrote it. In many cases, we've seen it, I guess, in the news as well. We've seen cases where these models were very eloquent, and they were able to persuade you that, oh yeah, this is because, and they come up with evidence. Basically, they fabricate evidence, right? And you don't want to have this.
Yeah, I remember an entire ChatGPT developing an entire branch of physics, I think, with citations, with references, with exciting sounding physics concepts, which are just completely false, but very, as you say, eloquently, very plausible, but completely false.
And to some extent, plausibility, it's not all bad, right? So these models are trained to be plausible, right? Because they want to be human friendly, and there's value in that, of course. But then, of course, we also need to think about the applications, right? So I think applications in the energy sector, given that they're safety critical and you're really having an impact, you're impacting people's lives, you really want to have safeguards, right?
Absolutely,
and a plausible answer is not enough, right? You want to have 100% guarantees.
Yeah, no, exactly. Like I know ChatGPT might be correct 80% of the time. That's obviously not going to be great for a system.
I suppose it depends on the application. If you're using large language models to, summarize reports, for instance, or even if you're using them to implement an interface, a user interface that is not really involved in the actual decision making, but it's more about making sure that users understand, the outputs of a model, then I think it's fine, right?
Yeah.
You don't need 100% accuracy or validity, right?
But when we come to people's lives on a minute by minute, second by second basis, we need it absolutely correct.
Yeah, I guess it would be a reasonable requirement.
So I'm going to come back to you, Dan, now. So I'm guessing that you have interacted maybe with regulators and policymakers in part of your post-note writing. So what are the current thinking about these kind of things that Francesco just brought up in this area?
Yeah, it is a topic that's starting to become more and more, they're starting to become more and more aware of. So with things like the data sharing framework, there's movements. So I think NISO is currently developing its digital spine to try and act as the intermediary to kind of hand out data from things like smart meters and kind of suitably decide who should be seeing which kinds of data.
Yeah.
And there is also a move from the government to try and think about explainable AI, and it's still very much in its infancy.
Yeah,
but they are more aware of these topics.
So it does. So there is some thinking about this stuff. It's not just we'll sort it out later on kind of thing.
Yeah.
So beyond the energy scope, is there sort of more general government guidelines around the use of AI in public sector critical systems processes? Do either of you know?
Do you want to start?
After you.
Okay, no, so I'm not familiar with specific, I for instance, I worked a lot, but this was with the US, so I worked a lot on using AI in aviation, and I know that there are clear rules there. Now, they are, as I said, I was working with a company in the US, so I don't know to what extent these rules are also, how similar they are. I would expect some degree of similarity. The requirements are at the end of the day always the same. You don't want to kill people. So I guess, yeah. But for other domains within, critical infrastructure, I'm not aware of how the regulation is. I don't know where we stand at the moment.
Sure.
Yeah, I believe the EU set out some principles for how AI can be used ethically and sustainably. Yeah. And I'd be surprised if there wasn't a move to model it on something along those lines.
Yeah, I think it's a fast-moving area because this is, I think, a very much of a difficulty with regulators and policymakers have when suddenly something coming along at incredible speed, and somehow we need to make sure that we can regulate around that area, especially in the energy field where it's been slow, suddenly fast. Like over the last 10, 15 years with the transition, everything has got a lot faster, and regulators really have to catch up. So just move back to explainable AI. So obviously that sounds like a very great concept. What are the challenges to implementing it? As in, are there drawbacks to explainable AI in other areas?
Yeah, so there are some risks, I would say. Privacy being one example, for instance, right? When you have an AI model that is explainable, it basically means that, I'm abstracting a bit, but it basically means that the model is able to explain, as I said, what the key factors were when reaching a decision. And sometimes these explanations are based on revealing information that is stored in the model, right? Yeah. So this would be potentially revealing information about other individuals or inputs that have been used to train the AI model, right? And when doing that, you might end up revealing a bit too much. So that is definitely one challenge around explainable AI. But then, of course, even just understanding how to implement an effective explainable AI, that is in itself a challenge, right? Because I guess I work on explainable AI, so I'm very much used to the notions of explainability and explanations that we computer scientists decided that are useful, right? But then, of course, I also have interacted with philosophers, I've interacted with social scientists, other people coming from other areas, and just lay users. In fact, they might very well disagree with what a computer scientist sort of sees as a useful explanation. So when it comes to energy, I see challenges both in delivering these explanations, making sure that you're actually explaining the right thing to the right person, but also making sure that these explanations are effectively capturing the underlying process, right, that the AI is modeling. So I think these are all interesting challenges. I wouldn't call them barriers. I like to be positive. So yeah, there's a lot for us to think about.
I guess that the field is coming along in leaps and bounds. So. And that is interesting. How do you make sure that the explanation is also correct? You need an explanation for the explanation. Does it?
Exactly. No, of course, yeah. Yes. You need to have. In fact, I've worked on this issue a bit. In fact, over the last couple of years, more than a bit. And the idea is, how do you make sure that I was working on a specific class of explanations, but nevertheless, how do you make sure that when you produce an explanation, how do you make sure that the explanation is robust? In my case, this was the problem that I was looking at. So, for instance, what if I slightly change a parameter in the AI model, right? Will the explanation still hold? So these are very interesting challenges, right? Because, of course, you want to be able to have quality guarantees, basically, right?
Exactly. Especially when it comes down to these critical applications, correct, where it has to be 100%. And just to finish off on this area, how could we tell if something's always going to be 100% accurate? Because that seems to be the big question here. If we want these models to be 100% accurate at all times, is there a way which you can prove that, or is it just...
So it's okay. So I will try to give a brief answer.
Yeah. I know this is getting into quite complicated.
But it's a very interesting point, because first of all, we have to realize that most of these techniques are they're based on statistics, right? So you're doing statistical learning. There's a lot of probability involved in the especially in the new sort of ML or generative AI kind of models, right? So by their own nature, I think it's very hard. It would be unreasonable to expect 100% validity sometimes, right? Because this is not how these models are built. This is not how they reason, right? They reason in terms of probabilities, and of course you can ask, I want 99% probability. Okay, good, but this is very different from making sure that nothing bad ever happens, right? Yeah. So that's one thing. Now, that being said, slightly more positive, there is a lot of work, at least in academia, in the research community, there is a lot of work on developing techniques to formally prove mathematically 100% that a bad behavior will never occur. Now, of course, this is a very complicated problem, right? And depending on the application, it's not even clear how this can be done, right? Because imagine if you're using an AI, imagine if you're working with images, okay? Then if you wanted to prove that a bad behavior will never occur, or that the AI will never say something negative, right? you need a way, you need a language to effectively capture these requirements while looking at an image, right? So I want to be able to say, oh, if a pedestrian is about to cross, for instance, autonomous driving is a classic example. If a pedestrian is about to cross, you should stop, right? But how can you actually describe this? How can you mathematically, how can you make sure that the neural network or the machine learning model, the AI model actually understands, that there is a pedestrian and that the pedestrian is about to cross, right? Sometimes I don't even know myself whether I'm going to cross or not. So this is clearly a challenge.
Yeah, and these are some very serious challenges. But I guess we do have some very smart people working on them.
Hopefully.
So obviously AI and its potential for getting things wrong is one I would call one of the three major challenges which I've heard the average sort of person on the street talk about when they talk about AI. The second one is the cost of training the model and running the model, both the energy costs and the cost of actually running it. And the third is consumer data, their data. Is it all going to be glommed up into an AI in a way which either their data could be exposed, as you pointed out, and touched upon earlier, Francesco, or just used without their consent, or I guess that they get anything for it. A company gets extremely rich off their data and they get nothing. So I thought we'd talk about data next. I'll bring you in for this, Dan. What have you discovered about how these companies are using data, especially when we consider stuff like consumer and smart meter data? Is there guardrails around that, guidelines?
Yeah, so data falls under GDPR currently, so it's protected, and so far it's mainly just DNOs, so the distribution network operators, that have access to that data. And what we see is from the other stakeholders, they wish they had more access.
Yeah.
But precisely how all of that data is being used isn't necessarily known.
Sure, so people have access to the data, but then we don't know where it goes afterwards.
If there's potential cases where it's maybe stored without being used actively now, but in the future there may be uses for it. So is there a kind of, I guess, balance between having enough data to make these models useful and keeping the more sensitive data away from them? Exactly, yeah. And there's a concern that it kind of moves slightly into cybersecurity almost, where when they have this private data, depending how companies are storing it, if that was ever to be exposed, concerned around being able to learn patterns of use, which would then maybe open up concerns for theft if you can learn when someone may be in the house or not.
Yes, I've heard this with people who've worried about smart meters. They can tell when I'm on holiday, they can tell when I'm away at work. So what are the regulations around smart meter usage from smart meter data at the moment? Who can access it?
So at the moment, I believe it's just distribution network operators, and NISO is working on being able to distribute it to other people that need to see it. Right. But I think that's still quite vague exactly who that will be at the moment.
Okay, and I guess they're also working on guidelines for privacy and use. And we actually published a paper on smart meter and anonymizing smart meter data while still attempting to keep it useful, which itself is a mathematical problem.
Challenge, yeah.
But yes, the idea of, and I've seen this in other fields, is the idea of getting personal data and anonymizing it to where it can't be traced back, but also still being useful for machine learning training is, I think, quite a big challenge.
Yeah, there's also, I think you also mentioned it in your report, federated learning techniques, where you have distributed data centers where that can be used for training, but you do not necessarily share data among data centers. So there are techniques to mitigate these issues. But then, of course, there are also so many challenges that I don't think we're even aware of at the moment, right? Because the moment we start using smart meters to do X, whatever, right? Predict usage, energy consumption, I don't know. Then I'm sure I can already see a lot of apps being developed, for, this particular activity being synced with your smartwatch, and then just download it on your phone, and then I don't know, it's everything is moving so fast.
It is, yeah.
And that's something that kind of came up in the interviews, is with AI, with the interconnected and maybe pulling data from different Internet of Things devices, it may potentially get to a stage where it's actually difficult to inform a consumer what exactly their data will be used for and what conclusions the AI might draw from different sources.
Right, so it's basically it gets drawn from different sources, and then at some point, several steps down the line, combined into something else. Yeah. So is this something that consumers should be worried about then, do we think? Is this something that the government and regulators should be concentrating on? or is this more of a barrier to?
I can start. So I think yes. Just like with any other application of AI, right? I think this is a concern. This is something that we need to make sure that is the way data is used. We should make sure that this is regulated. We should make sure that users are informed, right? Whenever their data, whatever it is, right? Whether it is smart meters or smart watch, or smart, you name it, we have to make sure that they know that their data, is being used. I don't know if I think you've seen it in the news recently. There was a lot about images from, being used, images being taken from social networks, right?
Yeah.
Social, I don't want to make, without giving too many details, we know that there are many platforms where we willingly upload content, right? And then this content is used to train AI models, and with our consent, right? But I guess many of us were not even aware of.
So I guess it's assumed consent almost here,
exactly,
isn't it? Like
exactly.
when you uploaded a picture you drew or something to a social network, that is, you weren't thinking, and you did it 10 years ago, 5 years ago, you weren't thinking this is going to be thrown into a great big generative AI model.
Exactly, yeah. And now, of course, I think the same concerns also apply to the energy sector, because, of course, once you start using smart meter data to understand how people use energy, then, of course, all of a sudden you can understand, the person is not home. They go to the gym every day, I don't know, at 6 p.m. And do I want an AI or a company? Because, forget about the AI. The AI is a concept, right? We have industrial and other stakeholders behind AI, right? So do I want these people to know what I do when I do it with,
And I guess this is a good point, because AI is just a tool at the end of the day in these regards. Like these companies are still going to be the ones deciding whether to use it for good or ill. Some companies are more open than others. I'm on the Octopus Agile tariff, and they have an open AI, API, so you can access your smart meter data in a half hour. You can do a fair amount of stuff with that, and there's a whole constellation of third-party apps designed around accessing that, seeing which is the cheapest Octopus tariff for you on those, and doing other interesting data stuff, which is fine, because at the moment you need to relatively opt in, and it's a relatively sophisticated process involving getting your own API key off a website, clicking through lots of boxes and that kind of thing. But when these processes become, I guess, transparent,
part of our lives,
part of our lives, there's a very different process towards opting in with your personal data. Absolutely. So, okay, so let's move on to the third question: cost of training, cost of running, energy costs. So this has happened. This has had a lot of traction with these large generative AI, large learning models, and we've seen. I think Microsoft's going to miss its carbon targets because it's, or at least they say they're assumed last year carbon targets, because the amount of energy they're using has gone up so much because of running these models. You've seen companies interested in small modular reactors to run their large learning things. I think Microsoft as well, has contracted with a 3 Mile Island nuclear power plant in the US actually, in order to get more power. So these models take a large amount of energy. So I guess the question is, is this the case for these energy models? Obviously, these large learning models are very different beasts to the predictive models. Can we do those more cheaply? And B, just more generally, is this something that we should be? Are there ways to make these processes more efficient? Because I know it's a big question for people. So, who lets that we do?
Yeah. So I would say from our consultations, one of the big concerns was data centers, which is the physical infrastructure that's going to underlie the functioning of the AI models, and the amount of electricity they use themselves. And it's about ensuring that any benefits that you might gain from the AI aren't negated by the cost of its energy usage.
Yeah.
And kind of also issues around computing power. So we see in the past few years there's been several moratoriums or pauses on the introduction of new data centers in places like Ireland, Singapore, and a municipality around Amsterdam.
Yeah.
Where there's a hold on building new data centers. So is there the capacity to actually?
We can't actually put the
roll out all these models.
Interesting.
And also, as an aside, there's a move to kind of move away from air cooling towards water cooling, and with data centers often being clustered around population centers because you want that quick connection. There's concerns about water sustainability and the amount of water that AI will need for that as well.
Very interesting. So yeah, they need a large amount of water, and also they'll be pumping out hot water somewhere, maybe back into a river, and that would be bad news. Yeah. So that is, I mean, these amount of costs are large.
But if I can chip in now, I think this is very true. But we should not forget that AI is not just generative AI.
No, absolutely.
So I think there is, and even within machine learning, huge field of machine learning, I think. For instance, if you want to train machine learning models for control tasks, right, not vision tasks, or not tasks such as NLP, natural language processing, like we're used to, I suppose. These models typically they tend to be smaller. They tend to require less power, to be less energy, to be trained. So I guess it's not all bad in a way.
Yeah, I mean, I guess that these more predictive models can be trained almost maybe not quite on a desktop PC, but
very much. I guess very much. Yeah, if you have a good laptop, I'm pretty sure. Maybe not on a tablet.
But you don't need a massive data center costing millions of pounds.
No, not
taking
for
hundreds of megawatts of energy.
Yeah, exactly. So then, of course, it really depends on the application. It depends on the scale of the application. I mean, I don't want to oversimplify things here, but I guess we should not forget that a lot of the energy that goes into AI is really, or anyway, when people talk about AI being power hungry, I mean, people really talk about vision-based tasks, NLP, large language models that do amazing things, but maybe they're not super relevant to applications in energy.
Yeah, and I think so. There's two questions here. First of all, how these big learning models, they use a lot of energy. Secondly, the models that we got now. The predictive AI models are very different beasts. They have much smaller data sets. They can run in a much smaller thing, and they're not actually going to take that sort of environmental sustainability issues. Yes.
Also, when at the beginning of this chat, we said that AI can be used to optimize decisions, right?
Yeah.
Or anyway, to plan and optimize. There's a whole area of AI that focuses on optimization, but it's optimization that is not data driven, it's again sort of good old fashioned, if you will, and of course for all these techniques they come with their own challenges, but definitely you will not need data centers if you were to use constraint optimization, for instance, or traditional optimization techniques. As I said, they have challenges. There are challenges there, but you can really use them without having to, cut down a whole forest somewhere in the world.
Yeah. So there is So I think this is the interesting thing with AI, as we've talked about a lot. This is a large area, and these huge neural networks, these huge machine learning. Large language models are very much at one end of a very big spectrum, which goes all the way to relatively small, very constrained, very precise models designed to do a very specific task very well, right? And there's not really a lot of definition, a lot of distinction between this in the public eye.
True, that is true. And to be honest, I think part of this, I suppose it's our fault as researchers and computer scientists. I mean, of course, big tech companies, they have more resources, more visibility, more power. They can, of course, be more vocal about their applications. But I guess many of us, computer scientists and similar, we've often enthusiastically followed, this general trend that, AI is working, AI is going to save us, AI is going to change everything. I think it's actually potentially true, maybe not, I don't know, but we have to be careful, right? And then when it comes to applications in energy, we need to make sure that when people say AI in energy, we understand, we map what AI can do for energy, what the requirements are for energy applications, and sort of think about if and how AI, some type of AI, which type of AI can actually meet those needs, right? So the conversation is very interesting, but I think it has to be done properly.
Yeah, I think researchers have a bit of a tendency, because I remember this when I was doing my PhD. I did a PhD in chemistry, and the big buzzword back then was nanotechnology. If you put nanotechnology in a grant, it was much easier to get than if you just talked about nanoparticles or got in. And I guess similar thing with artificial intelligence. It's similar thing with all these, and it obfuscates. It makes it more difficult to to do this for the layperson. Okay, so we've talked. How much time we've got this? Okay, so we've talked about challenges. So we're going to sort of finish off, I guess, with the thing both of you are most excited about for the future of AI in energy, as in what's the application which you think is going to be potentially, it could be something simple or it could be something more radical and far-reaching, but what do you think is going to change? What are you most excited about in the next few years? So I'll start with you, Francesco.
Okay, so I think when it comes to, say, technical challenges, what I'm really excited about is the idea of sort of coming up with a new generation of AI solutions that, and this is also a point that I made earlier, a new generation of AI solutions that can effectively reason about the physical process. And then how do we make sure, and there's a lot about this already, right? So I'm not coming up with a new topic, for the sake of this conversation. Yeah. A lot of colleagues have already done great stuff in that direction. But I think, for instance, I'm particularly interested in explainability, right? And then this idea of how do we make sure that if I'm explaining why I decided to switch off the turbine, in that particular region, for instance, how do I make sure that I can incorporate this knowledge about the physical process, right? And the reasons behind my decision? How can I incorporate this in the explanation, right? How can I make sure that I generate an explanation that is even plausible, but in terms of the physical constraints of the underlying process, right? So this is a very interesting technical challenge that I see. Then in terms of applications, I'm really curious to see, and maybe I also have I have a bit of an interest there as a consumer. Yes. I want to see where we can go with smart meters and if we can actually save some money or improve the way we use energy.
So I have saved some money on my Agile tariff. It's obviously not AI based. It's more just looking at the data and putting the washing machine on when it's cheaper. But it would be good if something did that for me automatically. So less good if it stole all my personal data and sold it to someone. So Dan, what are your thoughts?
Yeah. So I wondered if I could be slightly cheeky, because in the report we've narrowed it down to maybe 10 or so applications, and if I give some of the specifics, they're the kind of the main bulk of where the stakeholders see the value being.
And that's go for it.
Yeah, so the kind of first one is in the forecasting. So both the forecasting of renewable generation output using kind of meteorological data and historical reports to kind of predict the amount of energy that is likely to be coming from those renewable sources.
I've heard AI is very good at this, compared to more standard
I think
processes.
there was a study from NISO, and I forget which university, but I think they saw a 30% improvement with the use of AI.
As much as that, great.
But also forecasting of the energy load, so through accessing the Internet of Things and smart devices, using that data to predict the amount of energy and when it will be needed. So those two things together help you to better balance the grid.
Absolutely.
There's also things like automated smart grid management and demand-side response, so potential in the future moving towards AI maybe having a role in controlling the assets within a household and turning things on and off as and when they're needed.
Yep.
Yes.
There's things like automated frequency control, so kind of in the physical cables maintaining the stability of the grid and ensuring those quite complex calculations, which I think have to be simplified quite a lot because they need to be processed so quickly. Yep. If AI can do that instantly, then you can get that much more accurate, and the constraints on the grid are smaller then. Yep. There's things like predictive maintenance, so maybe assets and sensors embedded within the grid to measure both the thermal limits and maybe things like drone surveys on wind turbines and things.
It's basically fixing stuff before they break.
Exactly, which should reduce costs. But also in terms of, say, if there's an extreme weather event, AI could help predict which parts of the network are likely to be affected. Yep. And in the networks can specifically target where to place retrieval teams to basically reduce the downtime.
Yeah. Okay, so so basically everything from controlling your washing machine in your home to sending out a repair team afterwards.
There's optimized energy storage. So as we move to a grid with maybe more electric vehicles, that could potentially be looked at as an extension of the grid.
Yeah.
Where the charging and discharging of those could be seen as feeding into the system.
Yeah.
As and when energy is available.
So yeah, a lot of these are very interesting, traditionally complicated optimization problems that AI can, as you say, use statistical models to get more around. So without naming any of your stakeholders, obviously, where do you think the impetus is coming from? Are they DNOs and network operators themselves pushing for more AI? Is it large tech companies, or is it sort of smaller startups and smaller companies interested in specific niches? Where do you see the activity most happening?
I actually think it comes from everyone, but for slightly different reasons.
Okay.
Yeah, from all angles.
Yeah. So what are the different reasons, would you say?
So I guess for industry, there's economic incentives.
Yeah.
With the startups and also in academia, there's a push to kind of innovate and introduce these new technologies. And I'd say even within the policymakers, there's an awareness now that, it's not just coming, it's already here in some respects. So it needs to be addressed now.
So just to really finish off, what sort of time frame do we think we're looking at for the mass adoption of these systems? And I'm just saying generally here. Are we talking about this is something which the average consumer will notice in the next 2 years, or is it something which the average consumer may notice in a decade or 2 decades?
So I've heard a massive range from
Yeah,
stakeholders. Some that see this as in the next 2 to 3 years, huge, and others that think no perceivable difference in the next 10 years because of how slow energy could be to adopt into
how
these things.
conservative the industry traditionally
So there's
is.
not too much agreement on
I guess it's how optimistic you are. Any thoughts, Francesco?
And how big of a fan you are when it comes to AI, right?
Yeah.
No, I actually tend to agree with the more conservative estimates. Of course, I can see there will be some applications maybe where we will be able to see results, and we will be able to see change maybe more, within the next 3 years or so. But then when it comes to big structural changes, I don't think we're ready, right?
Yeah.
We don't have the technology, both in terms of AI and in terms of energy infrastructure, right? So it's going to be a long process.
And I guess maybe some of the earlier changes will be mostly apparent to engineers in control rooms and that kind of thing, rather than to the average person on the street. I guess, and then maybe it might ripple down. But yes, AI optimism is always interesting. I remember the self-driving car revolution was going to happen back in 2010. People said by 2025 we would all have self-driving cars, and
I was really hoping for. I hate driving. I hate driving. So I was like, yes, please AI.
Yeah, but these are just. I mean, it turns out that it's a difficult problem. And yeah, what works maybe in one area, like nice straight desert roads in Arizona, maybe doesn't work so well in a windy country lane in wintertime in Britain, for example. And I guess this is a kind of the range of what we can do as what's technically feasible, what's legally feasible, what's regulatory feasible, what's commercially feasible. I think are all different points along these things. So thanks to both of you. Thanks, Francesco, and thanks, Dan. And let's just finish off by saying, I guess, a little bit where people can find out more about you. So I'll start off with you, Dan, because you work in post.
Yeah.
So when's your paper coming out?
I think by the time this goes out, it'll have been published. So it comes out early to mid-December. And the briefing's called "The Future of Energy Security Through AI and Machine Learning." So they can find that there. And this has further details of applications and challenges, etc.
Brilliant. So I'm sure that'll be on the podcast notes, because I think this will be coming out in 2025 at some point. And Francesco, where can people find out about you? Just your webpage?
Yes, just my webpage, LinkedIn. I'm not a very social person, so I'm only on LinkedIn, but you can find me there.
Not a big social media fan. I can fit. Well, thank you for everyone for listening. It's been a great episode. Thanks, Francesco, and thanks, Dan. And hopefully tune in next time. Thank you.
Thanks so much.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content.